The purpose of this segment is to explain how not to graph in Excel. Well, we know that putting out a graph in Excel is fairly easy and it looks like you did a lot of work, but it's also easy to just make a lot of mistakes. I once assigned an open-ended assignment, and the results that came back were very surprising. With good humor, good sense of humor, the students allowed me to use their results in this lecture. So let's see what not to do. A graph should be self-contained, able to tell a story by itself. Your readers should look at it and say, "Oh, that's very interesting." The following examples are student work. The instructor wasn't responsible for any of these errors. And just watch and learn. This is example number 1. It illustrates the Series 1, Series 2 syndrome. Series 1 appears to be really close to 0 at the bottom of the graph, kind of a purpley line. Well, take a look at the worksheet. B2 through C7 is highlighted, and that's the data that was used in the graph. The charting utility is not able to distinguish between 1950 and 151 million. It thinks they're both numbers. The easiest cure for this is to simply delete the heading in B1 and then highlight from B1 through C7. It understands then that the data in column B is labels instead of being numbers. Some other problems with this chart: it doesn't have a title, so we don't know what we're graphing. It doesn't have formatting, characters, commas for the scale, which makes it difficult to read. Is it 3 million or 300 billion or what? Here's the chart redone. Perhaps the title could have been U.S. population growth. That might have been a little bit better. The legend was deleted because it's population. There's no need to repeat that. And you can see now that there are commas in the numbers, and it's pretty clear how the trend went from 1950 to 2000. This graph illustrates what happens when you highlight blank cells in a range. Notice again that there's a Series 1 syndrome, and also that the population scale on the left does not have commas. Let's see what caused that. Here's the data. You can see what was highlighted. Population, a blank, 2000, and another blank. This resulted in the blank area at the left of the graph. But there's one more thing that's strange. If you'll notice, the population appears to be decreasing. Take a second and see if you can figure out why. The numbers are listed in reverse chronological order. It would have been better to sort them in correct order, in chronological order, with January on the left. Then it would have showed a rise in population. This graph looked nice, but overlaying one with the other took away some of the axes, titles, labels, and so then you can't really see what's going on. In this slide we broke it apart. Looking at it, it would have been better to say population growth in the U.S. from 1800 to 2000. That would clearly identify what this graph was about, because we don't know if it's the population of some other country. I think you could omit the population over at the right, the legend. It doesn't really serve any purpose because we're already stating that this is population. And this is a correct use of a line graph. A line graph has to show change over time, and this one does. The other graph was percentage of change. Percentage of change graphs make me really uneasy. I don't think they tell the truth. Let's see why on the next screen. If you look at the data from 1790 to 1800, they had a 35% population change. It's hard to tell from this whether it was the 1800 to 1810 or the other way. Regardless, it's just something under 2 million people difference. But if you take a look at later figures, 1980 to 1990, we had a change of just under 25 million, but it's a very small percentage. Percentages don't always tell the truth. You can have one person out of 1,000, and if it goes up to 2 persons, you can say you had a 100% increase. And that's not necessarily a very accurate description of what happened. An alternative to the line graph would have been a bar chart. It would have shown the weight of the population a little more. And for the percentage of change, that could have been a line graph, but again, it still looks like we're going downhill, and we really aren't. Several students decided to chart race demographics for the state of Nebraska or Douglas County, and the next 3 or 4 graphs use this data. So this is a breakdown of the different races in Nebraska. Well, first of all, color-wise, it's really hard to read the black print on the dark blue background. White would have been better. Bolder font would have been better. The red clashes with the blue and is hard on the eyes. It's impossible to tell which one of the percentage labels goes to which pie slice. So that's just all pretty impossible. Let's look at the next slide. Here it's redone. It's improved, but not as good as it could be. Notice that the purple group has 89.6%. We'll need that in a later slide. This illustrates the chart in a chart idea. The small slice containing many other smaller pieces is broken down into a little bit of a bar. And that is an option that you can do when you have very, very small numbers. But I still have problems with the actual numbers. If you take a look at the bar, 0.38% is the maroon group, and compare that down to the pink group, which is 0.4%. They really should be about the same size, and they're not. Unfortunately, I do not have the original data and never did figure out why this graph was strange. Okay. This graph has similar problems in that Hawaiian is so small that it's just a thicker line there. But you can do a spell check. Did you notice that? Separated. Another thing is the way the main title is broken down, race hanging on a line by itself. You can do something with enter, and it seems to change from package to package. Could be shift enter, control enter, alt enter, but just go in and try it. You can force a word down to the second row of the heading. Let's take a look at the next slide. Here it's fixed a little. The heading takes up 2 lines, and we rotated the pie, but that brings up another little thing, doesn't it? Person needs to be a little bit sensitive. It looks like the purple slice are purple people eaters, and not a good thing. I also don't feel real good about the word separated. Categorized or just omitted entirely. Population of NE by race. Better to spell out population of Nebraska by race. Again, we don't have percentages or numbers, so it's pretty meaningless what the overall purpose of this is. Now, this chart is an example of numbers that are just way too different and should not be graphed together. First of all, we've got an estimate, then we've got a lower estimate and an upper estimate. Personally, I think I just go with the estimates. But even so, look at the numbers. In row 7, we have 374,000 American Indians. Does that tally with what you know about Douglas County in Nebraska? I don't think so. So whoever graphed this chart needed to look at their numbers critically and make sure that they made sense. In addition, having such small numbers as 6,000 compared to 374,000 means that you don't get good proportions on the graph. First of all, they need to fix the numbers, though. This graph might give the impression that most minority populations don't have computers. However, from a previous slide we knew that the white population was like 89% in Omaha, Nebraska. This graph doesn't tell the real story, such as what percentage of each race owns a computer. Now, okay, go with your stereotypes. Which group do you think actually has the largest percentage owning computers? Well, the class opinion at the time was Asian first, then white, then black, then Hispanic. Well, surprise! These statistics were for a group of 108,000 people surveyed. Hispanics came in first, with 71% of those interviewed owning computers. Then 65% Asians, 53% white, 33% black. This project missed the opportunity to graph some surprising data. If they had graphed the percentage of each group owning computers, that would have been a "oh wow" type of graph. Frequently the good stuff lies hidden until you play with the data. Don't just stop after your first attempt. Work with the data a little bit and see if you can find a surprise like that. Again, I think I'd fix the title, but I do like the way that the 3 smaller slices are exploded out. This graph has a legend with a lot of wasted white space because it makes everything the length of the longest one. I have no idea what %2000 parentheses a parentheses means. So what a person should do is delete that out of the labels in the spreadsheet. It would have been much more proportional. We've got 6 or 7 pie slices and only 5 entries, so we aren't seeing everything. We also have a problem with pie slices in that it starts at 12 o'clock with the largest slice. This makes the smaller slices recede because of perspective. You can rotate the pie so that the small slices are in front. This concludes the first half of this lecture. We'll pick up the second half at this spot.